Okay, this video follows on from the one that I've just uploaded, which is on distance time graphs. If you haven't watched it yet, make sure you watch that first, as that's the real introduction to forces of motion, and this is the slightly more difficult version of analyzing motion. So please don't forget to like any video that you watch if you found it useful. Even if you learned one thing from it, it's just a way of showing appreciation for the extra work that goes into making these videos. Share the videos with any of your friends who you know may benefit from watching them, and subscribe so you know when future videos are going to be uploaded. I'm spending a lot of time preparing students for GCSE, the mock exams, and these were ideal 20-minute videos for you to revise sub-units, so part of units, and there's been quite a few on the forces of motion topic already. I started with the more difficult content, and I'm now doing the introduction, which is motion. Distance time graphs has just been done, and this one is velocity time graphs. So today's video we'll be analyzing information you can get from velocity time graphs. For example, you can get acceleration, but you can also get the distance traveled. Okay, so without further ado, here's the definition of acceleration, which hopefully you already know if you're revising, and if you're in year 10, you probably have already covered this. So acceleration is change in speed, which is in GCSE measured in meters per second, divided by the time it takes to change that speed. So when you put it in terms of the symbols used in GCSE, it will be v minus u, where v is the final speed, u is the initial speed. And that's how we do it in GCSE and A level. A is the acceleration, small a, and t is the time taken. Okay, now because you're dividing meters per second by seconds, if you divide meters per second by another seconds, you get meters per second, and the way we write it, acceleration is therefore meters per second squared. Okay, so you do need to learn this equation. They don't usually give this in the exam. Okay, so the first test is a cyclist accelerates from 0 to 10 meters per second in 5 seconds. So that's v minus u, 10 minus 0 divided by 5 gives you the acceleration. So these you can do in your head. So that will be 10 divided by 5 will give you 2 meters per second squared. A ball is dropped and accelerates downwards at a rate of g, which is 10 meters per second squared for GCSE, for 5 seconds. Well, that's quite a height. If it's gone 5 seconds, you must have dropped it out of a window on a higher floor. How fast will it be going? Well, if it's going 10 meters per second for 5 seconds, the change in speed, if you dropped it from rest, u will be 0. V minus u will be equal to 10, yeah, a is 10, times 5, which is the time, so 50. It will reach a speed of 50 meters per second, so that's quite fast. And then in number 3, a car accelerates from 0 to 20, yeah, with an acceleration of 2 meters per second. This time they've given us a, they give us a change in velocity as 20, divided by 2, yeah, will give you the time. So 20 divided by 2 will give you a time of 10 seconds. And here they have a rocket accelerating from 0, yeah, when it's taking off, to 5,000 meters per second in 2 seconds. Well, that's quite fast. I'm not sure they can go that fast. So you divide 5,000 meters per second minus 0, obviously, v minus u, 5,000 minus 0, divided by 2 seconds, and you get the acceleration, which will be 2,500 meters per second squared. So that's a quick coverage of what acceleration means. And then you can also get acceleration information from velocity time graphs. So the steeper the velocity time graph, the faster the rate of acceleration, because the steepness shows how much the velocity is increased. The initial velocity was 0, the final velocity of this line was 60, and it took 10 seconds, so it would be 60 minus 0 divided by 10, a equals v minus u divided by t. Okay, so you can work out the numbers using the y-axis and the x-axis. If then the object stops changing speed, you know it's not accelerating. Okay, but it's not standing still, and a lot of students in GCSE get confused with the distance time graphs that I just went through in the video before this, and they say, oh, it's standing still. Well, it's not standing still. You can't be standing still and have a velocity of 60 meters per second. It's just not accelerating. So steepness is acceleration. No steepness means no acceleration. Less steepness means slower acceleration. Downward line means negative acceleration, and another word for that is deceleration. Okay, so now you can fill in what I've said. The upward line is the rate of acceleration. Yes, you stop the video, you sketch this graph, yeah, and then you fill in the notes, and this will be a concise set of notes for you to revise from. So the upward line, the steepness, tells you the rate of acceleration. A horizontal line means the acceleration is 0 because the steepness is 0. Yeah. The third line, the upward line, is less steep, means slower acceleration than number 1. And number 4, negative gradient or negative steepness. Negative gradient is the better term to use. Now in GCSE, the negative gradient means a negative acceleration because the speed goes from 80 to 0. So the final velocity is 0, the initial velocity is 80, so it's 0 minus 80 divided by the time it took, which was 20 seconds, so it will give you a negative answer. So it's a negative acceleration. A negative acceleration is also called a deceleration. Okay, hope that makes sense. So I want you to have notes on this. So use these videos to listen to what I'm saying and change my words into notes. Okay. All right. So here's another velocity time graph with acceleration, constant velocity, acceleration, deceleration, and this time they want you to use the information given, yeah, and to work out the distance traveled. Now, if the steepness tells you the acceleration, the area under the graph gives you the distance traveled. So, for example, if you're traveling at 40 meters per second constantly for 10 seconds, you know that you've done the distance you traveled is the average velocity, which is constant, 40 meters per second for 10 seconds. The distance traveled will be the velocity multiplied by the time you're traveling at a speed for. So it'll be 40 times 10. So this area will be 400. So the area under a velocity time graph is equal to the distance traveled in that section. So for a rectangle, it's easy. For a triangle, you need to know that the area of a triangle is half base times height because it's half a rectangle. Yeah, it's not traveling at 40 meters per second throughout those 10 seconds. It's on average traveling at 20 meters per second. So the average velocity would be half of the height. So that you could just use the area of a triangle being half base times height. So base times height divided by 2 is a better way of saying it. So it's 10 times 40, this times divided by 2 because you've only got half a rectangle. So if you can divide it up into triangles and rectangles, you should be able to answer all these questions. So the distance from 10 to 20 seconds is 400, which I've already told you. From 0 to 10 must be half of that, 200. And can you work out the total distance? That's a harder question, and you could make a mistake, but there's nothing in there that stops you doing it if you know the area of triangles and you divide it into sections which are rectangles and triangles and you work it out. Okay? I'm going to give you the answer in a minute, so if you want to stop the video and see if you can do it, and then once you've got yourself a total answer of the total area underneath that yellow line all the way from 0 to 50, yeah, then you can start the video again and you will see the answer. Okay, so answer is coming up on the screen now. Okay. All right, so 1700 meters is what you should have got. If you did, well done. If you didn't, make sure you check where you went wrong. Okay, so these are really useful quick revision videos for you to brush up on your math skills. Okay, more questions. Another graph. This time is asking you some basic questions. Number one, how fast was the object going after 10 seconds? You basically just got to read off at 10 seconds that it's going at 40 meters per second. Then they want you to work out the acceleration from 20 to 30. Remember, it's a change in velocity. So it's v, which is 60, minus u, which is 40. So 60 minus 40 divided by the time it took to go there to increase velocity, which is 10 seconds. Yeah? So you have to do v minus u over t, but this time you're getting the data from the graph, and the answer will be 2 meters per second squared. And the deceleration from 30 to 50, remember, is final velocity is 0 minus 60 divided by the time it took to do that, 20 seconds, minus 60 divided by 20 seconds should give you minus 3 meters per second, but squared. But they've said deceleration, so you can put it in the positive. Okay? And what is the acceleration from 10 to 20? Same thing, work it out. If you want to pause, the answer is coming up on the screen in a second. 3, 2, 1, and here's the answer. Okay? Some more questions for you to try. So David runs home to tell someone about his commendation. Yeah. This velocity time graph shows David's journey home. How far does he live? So they want you to work out the distance under the line. So if you want to pause the video again and then work out what the total area under that graph is. Yeah, remember triangles and rectangles, work them out in total. The answer is coming up on the screen now. 3, 2, 1. Here's the answer. Okay? And then we have one more problem like this. The velocity time graph shows someone else's journey to school. Sonny's journey to school. How far away does he live from the school? Again, you've got to work out the distance from the area under the velocity time graph. And that will give you the answer. So the answer is coming up on the screen. If you want to stop the video, try it out for yourself, and then see if you got it right. The answer is coming on the screen in 3, 2, 1. Here's the answer, 2,200 meters. Okay, more questions for you. So again, if you want to stop the video, these are self-assessed questions, and you should be able to work them out. I'm not going to go through them again. The answers are coming up on the screen, so if you want to pause, question 1, do question 1. The answer for question 1 will come in 3, 2, 1. Okay, now if you may want to pause to do question 2, yeah, which is the acceleration from 20 to 30 seconds. You work out what you think it is. The answer is coming up on the screen now, so if you want to pause the video until you've worked it out. 3, 2, 1. Number 3, the same. I'll give you 5 seconds, and I'm going to give you a countdown of when the answer is going up. Do the same, stop the video, try it out. 5, 4, 3, 2, 1, answer. And the final part is working out the area underneath it. How far did the object travel altogether, which is the total area under the yellow lines. And the answer is coming up on the screen. If you want to pause the video, try it out. 5, 4, 3, 2, 1, answer. Okay, thanks for watching. So we've now done distance time graphs, velocity time graphs, how to work out acceleration from the steepness, how to work out the distance traveled from the area underneath the velocity time graphs. So I'm sure you found that useful. So I'm looking for as many people watching it as I get likes. So really, anyone watching it should give me a like. What's there not to like? Share it with your friends. Subscribe so you know when the next videos are coming up. I think I've covered most of forces of motion, but I'll double check if there's anything I've missed out. I think maybe I haven't done Hooke's law. Okay, so thanks for watching. See you in the next video. Bye for now.